Okay, in this video I go over how to model non-linear effects or interactions. The easiest way to think of an interaction is drug effects. You may take this drug and it has this effect, and you take another drug, it has this effect. But when you take both of those drugs at the same time, you may not get an additive effect. You might not get this effect plus this effect. You may get a nonlinear and sometimes a really dangerous interaction. But how do we model that in a business sense when we're looking at data? So I'm going to look at this problem, and what we're looking at is a salary. We want to know a salary as a function of gender, and let's just use years of experience. So I want to know, how is my salary related to my gender and years of experience. So over here, the first thing I'm going to do, I've got to put the gender in a binary. We'll say 0 is male and 1 is female. So just to start, if this equals male, put a 0, let's put a 1. And also, I'm just going to grab the years of experience. Okay, so let's go build a regression model. And my Y range is going to be my salary. And my X range is going to be my gender and years of experience. Labels in the first row, I'm going to generate a new worksheet. So there you go, there's a model. And it's a decent model. The R-square is 0.49 and everything is significant. And let's look at the interpretation. It looks like what happens is that there's my intercept, and it looks like that the years of experience, for every year that you add, you're adding about $1,000. And it also looks like that women make $8,000 less. That's what that says. They make about $8,000 less. So whatever, if I had years of experience, so if I had a woman with 5 years of experience, then my salary would be the intercept plus the sum product of the sum product of these and these, 32,000. And then you have another year of experience that if you had a guy with the same thing, they would make about $8,000 more. Okay. Good model, it works, but let's look at the interaction. Let's look at a nonlinear effect of this and this. How do you model interactions? This is the most important thing, is the modeling effort. I want you to be able to model how do I model it? And how you model the interaction is really easy. All you do is take the product of those two. And that's it. So if you want to model an interaction, take the product of the two variables, and it doesn't have to be two, it could be more than two, but rarely do you do that. Usually you're looking at interactions of two variables. So that becomes what we have. So now we're going to do the same thing. We're going to model salary as a function of the gender, years of experience, and the interaction of gender and years of experience. Now it does create another variable. It's another variable, but that's okay. Under data analysis, regression. Now I'm just going to change my X range to add a third column. Let it generate a new one. Let's look at our model. And look what happened. Our R squared is much higher, much higher when we added the interaction effect. And if I look down here at the interaction, it is very significant. All of these are significant, but the interaction is significant. If it was not significant, then you would throw it out. But we see that the R squared increased. It's a very efficient model, and there is an interaction effect. Now, how do we model this? What do we do? Let's look at how to do the output. This is my intercept. This is a bump. This is a bump against, if it's a man or a woman, this is the bump on years of experience, but the combination of man or woman and interaction gives us an interesting effect. So let's plot this for different values. So I'm going to take these numbers and yeah, I'm going to take these numbers and I'm going to move them over here. Turn them sideways. So this is the intercept. This is gender. Wait, is that right? Yeah, gender. This is years, and this is the interaction. And then I'm going to look at for 0, 1, 2, 3. These are going to be years. Let's go out 20 or so years. And let's look at a guy's salary. And let's look at a girl's salary. All right, so how am I going to do this? This is going to be equal to the intercept plus 0, because it's a guy, times gender, plus the years times this, plus, now watch what happens, it's going to be 0 times years multiplied by the interaction. Look at what I did. I took the intercept, and if it's a guy, a male, then this gender variable is 0. So 0 times this, plus the number of years worked times the year coefficient, plus the interaction. Remember, the interaction is 0, because it's a guy, times years. Now, these multipliers that are 0, I don't even need to include those, but I went ahead and did that. But we know that this is not going to add any value. This effect, it's just really going to be the intercept plus years times the year coefficient. And I'm going to copy this down, so I'm going to put some dollar signs around all of my references to row 3 stuff. Copy that down. Now let's do it for a woman. Again, it starts again, the intercept plus 1 times the gender. We map guys to 0 and 1 to women, plus years times the years, plus, now my interaction effect, 1 times the years times my slope. Okay? Although that needs to be that. I'm going to put some dollar signs around it. Anything referencing these are all of my slopes. Put this one at the end. I shouldn't have, but that's okay. Copy that down. Now look what happens. At year one, what does it say? Women make more money. But over time, look what happens. Men make more money. Let's plot this with a scatter plot. Very interesting. This is what we got when we added the interaction. That depending on if you're a man or woman, your progression changes. Men start out with a lower salary, but their increase as a function of years is more steep than women. They start out a little bit more, but their progression over years changes. And we would not have got that if we didn't have the, if the original model, the bump was just strictly $1,000, and women always started $8,000 less. That was the rule. But that changes when you add the interaction. And remember how you develop the interaction, the whole trick to this, when you create the interaction nonlinear effect, you just take the product of the two variables and create a third independent variable. Thanks.